0 looks harmless. It means nothing. Empty space, no quantity. But the moment we try to divide by it, mathematics refuses to answer. The symbols are simple, 1 divided by 0, but the result is not a number. The calculator stops, the graph bends, the system says error. So what is 0 doing that is so dangerous? Why does this tiny symbol break the rules? If you like watching math mysteries crack open one rule at a time, subscribe my channel. Division is not a separate magic trick, it is multiplication played backward. 12 divided by 3 means split 12 into 3 equal groups. Each group has 4, and that is the same as saying 4 times 3 gives 12. So when we ask 12 divided by 0, we are really asking a reverse question: what number times 0 gives 12? That is where the problem begins. Multiplication by 0 sends every number to the same place. 1 times 0 is 0, 5 times 0 is 0, negative 100 times 0 is 0, even pi times 0 is 0. All the differences disappear. The input could have been anything, but after multiplying by 0, the output is always the same. 0 does not preserve information, it collapses it, and once that information has collapsed, ordinary division cannot reverse it. Now look at 6 divided by 0. If it had an answer, call it some number. That number times 0 would have to equal 6. Try 1. 1 times 0 is 0. Try 10. 10 times 0 is 0. Try negative 3, still 0. Try 1,000, still 0. No number works. Multiplication by 0 can only produce 0, never 6. So 6 divided by 0 is not a huge number. It is not hidden, it has no solution. But this is where intuition gets tricky. Look at the graph of 1 over x. When x is 1, the result is 1. When x is 1/2, the result is 2. When x gets very small and positive, the result gets very large. As x approaches 0 from the positive side, 1 over x grows without bound. That looks like infinity. But approach 0 from the negative side. Now the result dives downward without bound. It heads toward negative infinity. The two sides do not agree. More importantly, approaching 0 is not the same as being 0. A limit describes nearby behavior. Division asks for an actual value. Near 0 is not at 0. 0 divided by 0 is different. Now the reverse question is, what number times 0 gives 0? 1 works, 5 works, negative 10 works, pi works, every number works. That sounds helpful, but it is actually worse. A division result has to be a single value. Here, there is no unique answer. This is why 0 divided by 0 is called indeterminate. Different expressions can approach 0 over 0 and lead to different limits. X over x approaches 1. X squared over x approaches 0. Sin x over x approaches 1. The symbol 0 over 0 does not contain enough information to choose one answer. Computers also have to make rules for this. In many programming languages, integer division by 0 throws an error. In floating point systems, 1.0 divided by 0.0 may produce infinity. 0.0 divided by 0.0 may produce NaN, meaning not a number. These are engineering rules for computation. They are useful, but they are not the same as saying ordinary division by 0 has a normal mathematical value. The whole story comes back to one idea. A divided by b equals c means c times b equals a. For 6 divided by 0, we need a number that times 0 gives 6. Impossible. For 0 divided by 0, every number becomes a candidate, not unique. So division by 0 is not forbidden because mathematicians dislike it. It is undefined because the reverse operation breaks. 0 does not mean simple. 0 means the rules change. Thank you for watching.